I'm gonna do a demonstration of just like when I was working in partners, and even for ISPs who took on like LAN services, like the most kind of common LAN migration, and it was normally down to a refresh, so it would be like end of life kit. It was going into support. It needed to be supported. Obviously, you get some organisations that don't care if the kit has support on it, but most organisations do.
Sure.
So some prefer the spares rather than repair route, and they'll keep a couple of switches and run it into the ground until they absolutely have no choice. But yeah, most organisations have traditionally have a 3 to 5 year hardware cycle. That's all changing with the licensing, etc. But I'm not going to cover that. Yeah, we're always going to have like faster speeds and feeds with new tin being rolled out to support to provide supportability and support future technologies like the new wireless technologies and all that kind of thing. So, but yeah, specifically what you would see, or what I would see, I don't know about, you can comment as we go along, Daren, but what I'd normally see is like, so let's say here's your WAN. That's been migrated now. So
thankfully we're not going to do any more of
that. It's been migrated to a single WAN router and a single link.
Right.
Well, actually, no. Let's make it dual because it makes more sense. So typically, what we would have over here is something along the lines of I don't know, like let's say we had a switch stack at a site. That's a switch stack, and it has links like that to the WAN routers. And what we want to actually get to is let's say it's a bit bigger than that actually, and let's say what I would see quite often, this would be like a branch site as an example. Obviously, there's different level sites, but we're just talking in generic terms here. So what I would see a lot would be like 1, 2, 3, 4, 5, 6, 7, 8, 9.
Oh God! Don't do this to me.
Just an example, right? So.
Oh God.
Oh, actually.
I'll see this lack of hair, right?
This one's a freestyle.
See the lack of hair, right? What you've just drawn there, that's why I've got no hair, mate.
Yeah.
8 switch stacks. Oof.
So let's say these are the core, right? But it's actually just two. That's connected there. That's connected there.
Okay.
And then that's connected there, and that's connected there. Right. So this is like legacy switches and the legacy LAN, and then this is like a 48 port, and these are all 48 ports. And what I would see is like, for example, you would have server VLAN, you would have client VLAN, rarely, but you would have a management VLAN, etc., etc. And then you would, let's just say, same color, telephony VLAN, right? But you would also then, so this is like this is a collapsed core. These switches here are a collapsed core, and this is like the access layer.
Okay.
But you see here, this isn't like a very robust and modular design. So you might have like servers off here, and everything's basically, the point that I'm trying to get across here is like everything's like mixed across.
Everything's everywhere, yeah.
So what we want to get to is something along the lines of this is having a couple of core switches, so nothing much changes there, but they might be fiber, let's just say 24, fiber 24, and forget the technology, but they like whether it's stack-wise virtual, SDA, stack, whatever, they're fiber, two fiber switches that look like
VSS,
one. Right, VSS, yeah, whatever.
Anything of those, yeah.
Right, and then they've got connections to the router. Well, actually, that's not entirely mandatory. What we do here is what we're trying to do is like modularize the network. So here we've got like 9 access layer switches in the stack. But let's say like 4 of them are like actually needed for like clients and, well, let's say 5 of them are needed for clients and phones, and 4 of them are needed for servers, right? So what we really want to get to is this, or 5, and then they're connected somehow like that. And then from the server side perspective, we've got a couple of options where we can either, let me just draw this out. So clients blue, that's the default gateway for clients, and telephony, the default gateway is there. And then what we would probably want to do is have some sort of routed link to a server stack. Again, forget the technology, but server stack of some kind. So that could be Nexus, it could be actually just be a pair of catalysts or whatever. But the concept is that we're modularizing the network into, we're separating like the failure domains out. So, for example, if something wonky went wonky with this stack here, if you'd done a software upgrade, you would knock out all of this stuff.
Just everything. Yeah.
Whereas if you look at this, well, obviously management, you'd probably have like a management interface on there. Yeah, I would. Yeah. So yeah, if you knock that out on the left hand side, you knock out everything on site. Whereas like what we're doing here is we're trying to like modularize the network, and we would have multiple server VLANs, but like we just illustrate it like that. And we might have like some access. We might have like let's just say like a couple of access layer server switches as well that are physically connected like that, but the default gateway is basically the green interface.
The switches, yeah.
So yeah, however they're connected, and they operate like one. So then if you've got a server, you can have like redundancy and port channels and things like that. So that's kind of like the design that you want to get to. The next thing that we have to think about is like, right, so that's where we want to get to, but how do we actually get to it?
Yeah.
So there's a couple of ways. Like, you know, if we're retaining the IP addressing scheme, we can effectively let me think how to illustrate this. What we want to do is we want to interconnect between the old core and the new core.
Yeah.
And then our decision is, do we route between them, or do we extend VLANs? If we extend VLANs, so let's just say this is a, you know, a trunk port that I've drawn between the old core and the new core, and we want to extend VLANs like this. This one. Nearly missed a colour. So if we're talking like there's a gradual process. Obviously, we need to start moving like clients across, which would probably be the safest thing to do initially. So if you keep the same IP addressing scheme, as long as it can get to a default gateway, which then has connectivity to the DHCP server, then there's not really like any issue with connectivity. So let's rub these out for the moment, and say that that green one would basically go down there, and what we would have is the default gateways still reside on the side of the network. That one.
So basically what you've done is you've built your new infrastructure out in that sort of modular fashion.
Yeah.
And you've stretched the layer 2 from the legacy into the new, so that you can move physical connections from the endpoints into the new switches, right?
Yeah. So let's say this one server that I've drawn represents all the servers.
Yeah.
Right? And servers were the first thing to move. They no longer exist here, and they do exist here.
Yeah.
But for the immediate, score that one out as well. But for the immediate, the default gateway is still here.
It's still
but
there.
now that we have all the servers over there, what we want to do is basically remove that.
Yeah.
And configure it here.
Yeah.
As per the design. And that means that, in order to this would have to have some kind of like routed link over to like the old core
as well. Yeah.
Yeah. So is this looking all right from an understanding perspective?
Yeah. No, that's cool. The only thing at that stage, I guess, what you would do is prune back that green VLAN off the trunk as well, right?
Yeah. So that would no longer need to be extended.
Yeah.
I'll just rub it off there actually, because it's.
Yeah. That's cool. So you got the layer 3 link between layer 3 link between the server switches and the new core, and then a routed link from the new core back into the legacy network.
Yes.
Cool.
So then
that makes sense.
So then, like if we use green as the traffic flow is it routes to this green default, which is a default gateway.
Yep.
It then comes out the top of the server switches, which are normally routed to the core. Which then routes to the legacy switches, and then that would route up out to the WAN if it needed to get there. And the same migration methodology would also be followed for the other VLANs. So you would basically go through these sequentially and say, right, now all my clients are on there.
Yeah.
Management addressing actually would probably that's really just to manage the switches. So that's going to be on there from day one. But the gateway would be moved, I guess, when you have no requirement to, have these 48 port switches in the picture.
Yeah.
So let's just say, like, we no longer need to manage these, and all the phones are now, like, over here as well. So now, where we are is that we have moved our gateways. We would then move our gateways like I drew initially when I drew up this thing on the right hand side, where the voice data and management, this resides on a collapsed core. And obviously, like this can be designed a million different ways, because if a customer has requirement for a core distribution access or an SDA environment or something. This is really just a high-level concept.
Yeah.
You know, you might have like dedicated distribution layers and things on like huge sites, but the concept's the same. It's just you would move the default gateway over to these core switches on the right after there was no requirement for anything to be over here. So this now is completely gone.
Yeah.
In regards to the access layer. Now, when the access layer is gone, you then say, well, the access layer is gone. I've got a routed link to the old core, but I want that to be gone. So that's when we need to consider, I'll draw these in red so they're a bit more visible. We would then pre-provision, maybe not like at that point, but we might have done it in advance, but
yeah,
let me just prune those VLANs off here as well, because they're no longer required.
Yeah.
Over that trunk link. And that trunk link could effectively just become a routed link at that, or would just become a routed link at that point. Our next objective is to, you know, take this out of the equation because it's no longer required. And how we would do that is draw that first red line that I drew, and the second red line that I drew. Configure these as routed links, or it might be a /29, or it might be whatever, however you choose to do it. But now we have routed links from the new environment to the old. And how we basically swing that over is we can just shut down the interfaces, like here, for example. And if there was a dynamic, even if it was static, as long as the default route was in place to pump over these, you know, these lines here, and there was a route back to this whole new environment, which the only real change here from the, you know, from the WAN router perspective is the next hop, instead of it being to these legacy routers, they're going to be to these ones over here.
The WAN termination. Yeah.
And that has all the ongoing routing. So at this stage, you know, we basically don't have any of this anymore. And the kit gets decommissioned, etc. And I'm explaining this as if it's like a stepped process and you've got loads of time. But the reason that you need to understand this clearly is the reality of it is all of that I just explained is likely, well, you would probably pre-build everything that's on the right-hand side ahead of it even arriving at site, and it will have been tested in a lab. But all of that migration stuff would probably happen on a Saturday, or a Saturday and a Sunday.
Yeah.
So you have to have your plan in place, and you have to have it squared away to understand exactly what the dependencies are, what the migration plan is, and how you're going to execute it.
Yeah, I think, and it's really, really important. I think I was going to ask you about that. The order of events that you've specified there, I think is optimal, and I think it should be that you go through every one of those steps, right? Because if you don't, if you just were to walk in there and just cut everything over, just change all the physicals around and just repatch everything and then move all the layer 3 and all the rest of it all in one go. If something goes wrong, try unpicking it. Try going back and working out where that's gone wrong because you can't, right? It's too much change in one go, right? From my perspective, my experience, I've always found that by doing exactly what you've just done there and walk through, i.e., put the new stuff in place, hook it up at layer 2, physically move everything across so that it is able to continue to operate at layer 2, but with the layer 3 still in the legacy, move the default gateways across, and then swing the WAN across. If you might choose to do that in a slightly different order, as you say, but essentially to take that approach. And then at each point, be doing your testing at every step along the way so that you can back it out so far without having to back the whole lot out or whatever. That approach is gold dust because it just makes troubleshooting so much easier because you're only changing certain things at certain times.
And that scenario that I explained, probably, to be honest, it could be done over a weekend, like everything, but the likelihood where it's mainly when the servers come into play. Like, because even if it's like a branch site, you might have servers that are business critical, and it's when the servers come into play. If that was just like voice and data, to be honest, you could probably you wouldn't need to do the parallel running, and sometimes that's not possible because of like rack space, power, etc. And that opens up another conversation. But if it was just data and voice, the likelihood is, we wouldn't have to have gone through all that stuff. I probably should have said that at the start, but it's really when there's servers and critical services in place that need to be moved from one infrastructure to a new infrastructure, whether it's VM, physical, whatever, in the same location. Even if it's in the same location, it might be in a different building or a different they might be moving comms rooms, Yeah.
And you will end up splitting it up in that way. You will end up doing the layer 2 and then stopping and testing it. And that testing, it may not be till the next week that you get another window, or you may carry on and within that change window, then move the layer 3 and then test again, so I think the pattern that you've described there is spot on. Whether you're doing everything all in one go, or if you're doing it spread over a number of weekends or whatever, just simply because you've got really clear lines there as to, right, do this thing, test it. Then there's a back out point there, but you don't have to go back out all the way back to the very beginning. You only have to go back as far as the last test. I think
I was going to draw a better picture of what that actually looks like at the end. So, basically what you've got is, forget how many switches here. This is your access layer stack. And then you've got your server stack and your server access layer. Server access, server core or distribution, I should say. Server distribution, probably something like that. And then it's a nice, like from a layer, I'll just use this, from a layer 3 perspective. That's where, layer 3, layer 2, something along the lines of that. And then for the clients, it's like that. If it was like a collapsed core. But what that means is, like, in the old scenario, if like the switch stack failed or something like that, everything was taken out. Obviously, at this point, like if the collapsed core was taken out, and both of them were taken out for whatever reason, you would lose everything in the site. But that's like, there's only so much redundancy you can go into, because the same thing would happen, if the WAN link. If the WAN links are like this and you lost both of them. So if you keep adding more and more redundancy, like a good number is 2, a maximum is 4, but I think personally 2 is the maximum that you should have of anything. So if you had for example 2 WAN links which were private WAN links, you might want to put a couple of internet links in case both of them fail. But I wouldn't put 4 like MPLS links in, for example. And the same goes like I wouldn't put 4 core switches in or 4 distribution switches in just to service. That's where you start looking. I think personally where you start looking at geo resilience, but resilience is another topic. One last thing I just wanted to mention on this stuff over. And we won't go into the detail, but in regards to stretching the layer 2, one of the things that I've done, like we put a scenario there where you had to go. I if I draw this like traffic flow back, it had to go basically up here and then over to the old side and then back. One of the things that you could potentially do is for, well, that was a bad example. If it's thinking about if it was the blue would have to have gone all the way back like that. But what you could potentially do is like make the blue one that I seem to have rubbed out, the blue default gateway part of a HSRP or a VRRP group, and you could make it like lower priority. So initially it broadcasts back over here because you know it works, but when you've got all your clients, when you've got all your clients migrated over to here, you can then say, make this my default gateway, and it goes there, and then from there it routes. So you change the priority on the HSRP interface to, so there is layer 3 on that side. It's just not effectively active until you change the priority of the HSRP. Yeah.
Yeah, I mean that again slickens that migration process, doesn't it? Of moving the layer 3.
It makes it almost like hitless, but it's if you've got the luxury of having the environment stood up in parallel, and you don't always have that. But to be honest, as I said, if you don't have rack space, you don't have power, and it's like swapping a like for like, then it's not actually as complex because you're literally just putting the config on that you had before on your kit.
Yeah, agreed. I think, always aim for the parallel build if you can. This is the moral to that story.